AWS Amazon Relational Database Service (RDS). Description: fully managed relational database service that provides access to various database engines, such as MySQL, PostgreSQL, Oracle, SQL Server, and Amazon Aurora. RDS handles the administration tasks, including provisioning, scaling, backups, and security, allowing you to focus on your applications. Prerequisites: AWS account. An active AWS account is required to access and use RDS. Basic understanding of relational databases. Familiarity with relational database concepts like tables, queries, and schema design is helpful. Use cases: web and mobile application development. RDS provides reliable and scalable database infrastructure for web and mobile applications, handling large volumes of data and concurrent requests. Data warehousing. RDS can be used as a data warehouse for storing and analyzing large datasets from various sources. Business intelligence. RDS supports business intelligence applications by providing access to data for reporting, analysis, and visualization. Data analytics. RDS can be used for data analytics tasks, allowing users to query and analyze data to extract insights. Step-by-step implementation of general use cases. Create an RDS instance. Launch an RDS instance by choosing the desired database engine, instance size, and configuration options. Configure database settings. Set up database parameters, such as port number, character set, and authentication settings. Connect to the database. Establish a connection to the RDS instance using appropriate database client tools and credentials. Challenges and fixes. Database performance issues. Optimize database queries. Analyze query plans and identify inefficiencies, such as using appropriate indexes, avoiding unnecessary joins, and optimizing data types. Increase instance size. Scale up the RDS instance to accommodate increased workload and improve performance. Use read replicas. Create read replicas for read-only workloads to distribute traffic and reduce load on the primary instance. Use database caching. Implement caching mechanisms, such as using Amazon ElastiCache or Redis, to store frequently accessed data in memory. Use connection pooling. Configure connection pools to manage database connections efficiently, reducing connection overhead and improving performance. Optimize database configuration. Adjust database configuration parameters, such as buffer cache size and query optimizer settings, for optimal performance. Security concerns. Use strong passwords. Set strong and unique passwords for database users and administrative accounts. Enable encryption. Encrypt data at rest and in transit using SSL/TLS to protect sensitive information. Implement access control. Define access policies and roles for database users, restricting access to specific databases, tables, and operations. Use security groups. Create security groups to control network traffic to and from the RDS instance. Enable AWS ING authentication. Integrate with AWS Identity and Access Management ING to manage user permissions and access control. Use Amazon VPC. Configure the RDS instance within a virtual private cloud VPC to isolate it from public networks. Monitor for security threats. Use AWS security tools and services to monitor for potential security breaches and vulnerabilities. Dash. Cost optimization. Dash. Use reserved instance. Purchase reserved instances to commit to using a specific instance for a set period and receive discounted pricing. Dash. Utilize AWS cost optimization tools. Leverage AWS cost optimization tools such as AWS Cost Explorer and AWS Budgets to analyze and manage RDS costs. Dash. Consider using smaller instance size. Choose the appropriate instance size based on workload requirements to minimize costs. Dash. Optimize database configuration. Configure database parameters to reduce resource consumption and improve efficiency. Dash. Use automated scaling. Implement automated scaling to adjust instance size based on workload fluctuations. Optimizing costs. Dash. Use AWS Lambda for periodic tasks. Utilize AWS Lambda to run periodic tasks such as backups or data processing only when required, reducing instance costs. Dash. Database backups and recovery. Dash. Enable automated backups. Configure automatic backups to create regular snapshots of the database, ensuring data protection. Dash. Use point-in-time recovery. Recover data to a specific point in time using point-in-time recovery capabilities. Dash. Implement disaster recovery plan. Create a disaster recovery plan, including backup strategies and procedures for recovering data in case of an outage. Dash. Use AWS Backup. Utilize AWS Backup to manage and automate backups of RDS instances, enhancing data protection. Dash. Enable backup encryption. Encrypt backups using strong encryption algorithms to enhance security. Dash. Use AWS KMS. Leverage AWS Key Management Service (KMS) for managing backup encryption keys, ensuring security and control. Dash. Database migration. Dash. Use AWS Database Migration Service (DMS). Migrate databases between different platforms and engines using AWS DMS, simplifying the migration process. Dash. Perform manual migration. Manually migrate data using database tools and scripts suitable for smaller datasets or specific migration requirements. Dash. Use third-party migration tools. Utilize third-party migration tools, including commercial or open-source solutions, for specialized database migration tasks. Dash. Use AWS Schema Conversion Tool. Utilize the AWS Schema Conversion Tool to convert database schemas between different versions or platforms. Dash. Use AWS CloudFormation. Automate database migration using AWS CloudFormation templates to create and configure resources, including RDS instances and database migrations.